In June 2009, Air France 447 fell from 38,000 feet into the Atlantic Ocean. The aircraft was not broken. The engines were running. The pilots did not recognize they were in a stall. I'm FLT-LAB, and today we're studying stall and spin dynamics, the aerodynamics that every pilot must understand to survive.
We'll cover what a stall really is, how angle of attack controls it, the warnings your aircraft gives you, how a spin develops, and the recovery procedure that could save your life. This is general aviation education, not certified flight instruction.
A stall is not about speed. A stall happens when the wing exceeds its critical angle of attack, the angle between the wing's chord line and the oncoming airflow. Past that angle, the smooth airflow on top of the wing separates, becoming turbulent, and lift collapses almost instantly.
Angle of attack is the single most important angle in aviation. Increase it and lift increases, up to a point. That point is the critical angle of attack, typically around 15 to 18 degrees for most airfoils. Beyond it, the lift curve breaks. The wing stops flying.
When the stall breaks, the nose drops. The aircraft loses altitude rapidly. In a clean stall, recovery is straightforward. Reduce the angle of attack, add power, and let the wing fly again. The problem is recognizing it fast enough.
Modern aircraft warn you before the stall. A stall horn sounds at 5 to 10 knots above stall speed. In larger aircraft, a stick shaker vibrates the control column. You may also feel aerodynamic buffet, a shaking in the airframe as the airflow begins to separate. A spin begins when one wing stalls before the other. The more stalled wing drops, creating more drag and yaw. The less stalled wing keeps flying, creating a rolling force. The aircraft auto-rotates, rolling, yawing, and descending in a corkscrew path.
In a fully developed spin, the aircraft rotates around a vertical axis while descending at a steep angle. Descent rates can exceed 5,000 feet per minute. At low altitude, a spin is almost always fatal. That's why prevention matters more than recovery.
The standard spin recovery is PARE, power to idle, ailerons neutral, rudder opposite the spin direction, then elevator forward to break the stall. Once rotation stops, smoothly recover from the dive. Every second of hesitation costs altitude.
Stalls and spins usually happen because of distraction, low airspeed in the traffic pattern, steep turns at low altitude, or abrupt control inputs. Icing can raise the stall speed dramatically. The common thread, the pilot lost track of angle of attack.
To recap, a stall is an angle of attack problem, not a speed problem. The wing stalls past its critical angle. One wing stalling first starts a spin. Recovery is PARE, reduce power, neutralize, opposite rudder, forward elevator. Prevention beats recovery every time.
Your takeaway: always know your angle of attack. Fly coordinated turns. Manage your airspeed in the pattern. And if the stall warning sounds, reduce the angle of attack immediately. If you found this helpful, like and subscribe for more aviation content from FLT-LAB. Question for you: have you ever practiced stall recovery in a training aircraft? Tell us in the comments.